This week we're going to continue our discussion from last time where we got into basically classes, and it's a big, deep end of the swimming pool to step off into, so it's a lot of material to wade through, but it's good stuff. This is all practical things that are going to be necessary for you to be good Java programmers. You can only do the simple one function programs for so long using structured programming before you have to make that switch over to object-oriented programming, because that's what most people that are going to be doing Java are going to need to know. So we got a good chunk of it last time. I think we got up until the structured comments and creating Javadocs, which is again ubiquitous in the Java world. If you're going to write Java code, you're going to need to add those structured comments to your code, because most companies that I'm aware of will expect you to put that in your code and be able to produce Javadocs regardless of what they end up doing with it. So let's jump right in. So yeah, the first one is Javadocs, and we're going to continue talking about more of the usage of classes and the different aspects of classes. We talked about methods and properties last time. We'll get into more of the usage of those. So you've got this class over here. Now let's create some code that creates instances of that object, manages them and manipulates them. And then we'll get into some of the other variations like different constructors, copy constructors, things like that. And yeah, we'll see how far we get today. Hopefully I don't have to break this up into a third lecture for next week, but that means I'm going to have to be focused and not go off on tangents like I usually do. So here we go. So a little bit of the history of structured comments. It's been around for a long time. It's nothing new. It wasn't invented for the Java language. What I remember the earliest time I came across it was called Autoduck. I think they were making a play on Autodoc. But it was just some program that somebody wrote. And so you had hundreds of C++ programmers at Windows that were or at Microsoft creating C++ code for the various programs, Word, Excel, PowerPoint, all the different programs that Microsoft created back in the day. So there was a lot of C++ code. And if you moved from one team to another, which they tried to encourage that to kind of cross-pollinate methods and standards across teams, then it was a big learning curve to join a new team and to have to try to get up to speed on what their code was and how it worked. So comments were needed. Problem was developers hated doing comments, and it was like pulling teeth to get them to actually write the comments so that other people could benefit from them. But they came along with this this interesting thing. If we just formatted our comments in a certain way, then we could write this separate program that goes and just reads all the files in the source code library and opens up each one of them, scans them, ignores the code for the most part, and pulls out all of those structured comments. Then with those, it would wrap them in HTML code and format them nicely with headers and nice paragraph styling and things like that. And you'd have a bunch of web pages that you could then open up and browse and peruse all the classes and functions and methods and everything that were in your C++ code. So it worked really well if you could get teams to actually use it. So that was the first time I was introduced to it. When you're going from a big project with thousands of lines of code that doesn't have this stuff in it, and you want to go from that to code that's thoroughly commented, it's an uphill climb. But if you could get into a team early enough where they hadn't created a lot of code, or it was a new project that was starting up, sometimes you could get the developers to create the comments as they created the code. And this is one of those common dichotomies in software, is there are a lot of aspects that you can add to your code to increase the value and the benefit of the way that you generate your code, but nobody ever can justify the time that it takes to stop working on producing new features for the program, and let's just take a couple of weeks and go back and make all of our code look prettier. which is often what the managers think you're doing. It's like, no, we are actually addressing technical debt, and we're investing in our code base so that in the future, again, we'll be able to more quickly cross-train developers. We'll have a better understanding of our code from a high level. There are intangible benefits to doing some of these things to your code, but it's really hard to justify from a financial perspective, especially if you're some little startup that has your series funding and you want to be spending it as judiciously as you can. But when we get to Java, we're talking basically about Javadoc. There may be other versions. I haven't Googled in a while to see if there are other versions out there of this, but like I said, Javadoc is pretty ubiquitous, and the great thing is, it is so ubiquitous that it is built into IntelliJ. IntelliJ doesn't do it, but like a lot of things, IntelliJ just has hooks to where if you put the comments in your code, it'll syntax color things nicely for you, like it does for all your source code. It will have menu items where you can compile and run your code, but then you can also pick another menu item that says, okay, can you go run the Javadoc utility against my code and give me the output? So it will call the program for you to make it convenient. So that's what we'll get into. And again, yeah, it just creates typically the content as HTML. I don't remember if it's got other output formats, like if you can have it skip the HTML and just go directly to like a PDF file. But I'm sure there are programs out there where you can say, hey, all of the HTML in this folder, can you convert that to PDF? Worst case, you just use the print function, and that's become pretty useful nowadays, is just printing to PDF. So there's ways you can get it from HTML to PDF, I'm sure. And then there's this reference out here that I gave you the link to. This guy, that's his last name, I think, Belden, or pseudonym or something. But he has a good reference on Javadoc examples, how to use it, how to leverage it. Probably goes deeper into it than I'm going to require you to do in here. I just want to make sure that you know that you should be doing it, how to do most of the basic things in it, that you kind of make it a habit from now on. I'll expect it when you turn in Java code that it's going to have these comments. And, you should take it upon yourself in investing in your own experience how far you want to go into utilizing all the breadth of features in Javadoc. But the fact that you know how to use the utility javadoc.exe to create the Javadocs and open them up and view them, where whatever folder it puts the HTML files in, that's the part that I want you to get across as the machinery involved, and start developing that muscle memory so that you form the habit of doing it. But further than that, you guys can just knock yourselves out as far as you want to go in investing in it. It is one of those things where there's a lot of these different aspects of coding that I try to tell people, if you're going to be going out there in a tough job market and somebody does give you a chance to be an entry-level Java developer in their team, if there's something that you can be a resource to the team and answer questions to the team about, every little one of those things gives you an edge, and that's the name of the game, is you want to make yourself valuable to the team. There was an episode of How I Met Your Mother where one of the characters was afraid of getting fired at his company, and they were all trying to figure out a way that he could distinguish himself. Are you going to be the poker night guy? Are you going to be the snack guy? Are you going to be the back rub guy? But they're all funny things, but when it comes to actual software development, if you're the person people go to ask for, hey, how do we do this in Javadocs? Or I saw that cool thing you did in Javadocs. How did you do that? Can you tell me how to do it? Or improving standards overall, or explaining to managers the benefits of doing structured comments and making those intangible benefits that they perceive a little bit more tangible for them to understand what the real benefits for cross-training and other things like I mentioned are. Anything that you can do to give you that little edge, it's just investing in yourself is the way I look at it. There's another one I want to mention before we go do the practical stuff on this, which is Swagger. You'll see that mostly used in web services, whether it's C# or Java. People will typically it's the same thing, you just put structured comments in your code, but how you extract them out and make them available. The cool thing about web services and websites is the presumption is you're already running them and publishing via a web server, right? So there's some web page address that people are going to use to get to that service or that site. Well, Swagger does a similar thing to what Javadoc does, but instead of producing just a folder full of HTML files that who knows what you're going to do with them, or a PDF file if you choose to, it creates a subfolder inside your project itself as part of the build process. So as you're building your code, an extra step is to go build and extract out these structured comments and place them in the folder. And then once they're there, the people viewing your site or accessing your web service can also access these HTML files so that the documentation is sitting next to the code that you would need to use the documentation with, that sort of thing. Do you have a question?
Isn't Swagger IO for backend for API?
Yeah, for web services, for backend, yeah, typically we would think of that as middleware, but yeah, it's very useful. I mean, when I'm writing code at home, I use it myself. One of the cool things that Swagger also gives you that Javadoc does not is the ability to actually invoke your code. If you're using Swagger and you're generating these comments against a web service, there are actually links in the Swagger content that you can say, hey, I want to actually call that web service method that you have documented for me, and you can type in the parameters, and it's basically no different than calling that curl utility that manually sends HTML request or HTTP requests to your server and then shows you the results, the result codes that you get back and things like that. It was very powerful though. But circling back to what we're going to be doing, it's no different than just the beginning is just get self-disciplined into putting the comments into your code to start with. Yeah. Okay, so here's the gist of it. So before you put anything in your file where you're going to use these structured comments, you're going to want to start it with a comment block. And as you can see, there's just basically an extra asterisk. So instead of /*, you just put an extra asterisk. And that's what the Javadoc utility is going to look for is, oh, this is one of the comments they added for me. Or this is a comment that I should process, as opposed to comments that, oh, I can ignore those comments. So that's as simple as it is. You just do your normal comments. You just put an extra asterisk at the beginning of it. One of the great things about C# and Java, as opposed to a language like C++, is that the compilers are much more open. The compilers were developed much later than the compiler for C++. And so, and also I think the fact that we're generating bytecode or intermediate language code like with C# means that the code can actually query itself. Like in your code, you can use reflection to actually ask, is there another function with this name and these parameters, that sort of thing. Well, that also empowers tools like Javadoc to be able to use those reflection parameters to ask things about the code. So whereas before in the more primitive versions of these things, the autoduck from the early C++ days, you would have to type everything about your code in the comment for autoduck to pull it out. With Javadoc, you don't have to. you basically have to give it what the humans would want to know about it, the description information. Because the list of parameters, the name of the function, all of those kind of things, it's going to be able to pull out of the code itself. And it makes it really convenient because, you know, in the old days you had so much duplication was the complaint. I just defined the function. Why do I now have to put comments about every parameter in the function? The name of the name of the parameter, or the type of the parameter, and what it's used for. Well, you don't have to do that with Javadoc. It's very powerful. But the descriptions, like if you're going to provide the description of a parameter, use the @param. If you want to document what the return value is, use the @return. If you want to have a reference to some other place, like let's say you've used some encryption library in your code and you want to give people reading your code a link to some specification document that explains how this encryption works. You don't have to reproduce that documentation there. You can just put a link to a see also kind of a thing. And you can see, you know, again, all of the different things that are possible here. And for more, go to that link that I gave you, or you know, just Google Javadoc and look for other reference material on it, because it's pretty powerful. And like I said, we're only going to get to the top level of this stuff. Is my goal. So here's an example. As you can see at the beginning of the file, it starts with the /**. We have a description. The @author is nice, in case you want to look up who in this company actually wrote this method. Those can become kind of stale over time and people can leave the company. But I would say it's still nice. And if you're going to edit this, it's bad taste to replace the author with your name if you weren't the one that wrote it. You know, I've never had a manager come and complain that I plagiarized, you know, or somebody plagiarized because they did this. But what you want to do is just put a comma at the end and add your name to it if you contributed to the method, because that's all they're looking for, is a list of people that they can go ask if there's a question about how this method works. And then the version, you don't see a lot of people use the version because we don't really think of versions of methods and stuff. But you know, there's some context where that can be important. I'll give you an example. One of the companies that I worked for, they wrote a suite of tools that allowed you to manage documentation. And you know, it took me a little while to figure out where that would be useful. Why would anybody buy a product to manage their documentation? But it turns out if you're a pharmaceutical company and you're producing a drug like, let's say, Tylenol, because that's been in the news recently, all of the information, the risks, how it was manufactured, how the testing process, I don't know what the breadth of all the documentation that they have to have, but I know that the FDA requires volumes of documentation on a new drug. And so every time the company would want to go change a line of code, it had to be, so they'll have some technical writer or some, I guess, medical writer change the line of documentation, and then it would go through a change review process where several layers of doctors or scientists would have to review the wording change and approve it, and it'd go on to the next level. And then at the end of this process, when you went back to the FDA would want to see the before and after of all the changes and the audit trail of every wording change of that documentation that went along with it. Well, that's a lot bigger job than you're going to be expecting something like Microsoft Word to manage for you. Okay, so that's why they were developing this. And so likewise, there was a lot of scrutiny on the software that was written by this company to generate, you know, all that documentation. And so there might be some context. NASA might be another context. You know, if you're modifying the code for the Mars rover, maybe they want to version every single thing down to the nth degree so that they can backtrack what was it that caused the rover to go into a pit and not be able to get out, that kind of stuff. But, you know, typically in a regular old development environment, rarely have I ever had any kind of an urge or a pressure to use the version thing. And I think that's going to be the same with a lot of these attributes. Know that they're there, understand what you would use them for, but most of the time you're just going to use the basic description. Oops. Where'd it go? There it is. Okay, so when I use the Javadoc tool against this, I'm going to get, you notice this says signs.html, same name as the source code, .html. That's the file that Javadoc created when it read this source file. And it put a bunch of this stuff in here. The signs class derives from java.lang.object. As we learned last time talking about classes, everything derives from object. So essentially this is a base class. Here's my description. This class accepts a binary digit. So yeah, that's what I typed in right here into this comment. So all it did was extracted that comment and stuck it in here at this point in this HTML file. Then down below it's going to list all of the methods and properties and constructors and everything that it pulled out about that class. So that's at the very basic level, that's all we're doing. We created a Java file that had a bunch of structured comments in it, and then we used the javadoc.exe program against that Java file. It read that Java file, pulled all the comments out, and created an HTML file, and that's what it looks like when it's done. So like I said, use the Javadoc command, or in IntelliJ you can use tools Javadoc. And so I always have people not listen when I say this, but when you are asked to turn in, like with this next assignment, your Java file and your Javadoc file, I get questions, how do I generate the Javadoc stuff? Well, I'm telling you right here, in IntelliJ, if you're using that to manage your code, you go to the Tools menu, Javadoc, and it basically runs the javadoc.exe program for you and puts the HTML file somewhere. So that's the other mystery part of this. When you're using the Javadoc command from a command line, you give it a parameter. You say Javadoc and you give it the parameter of where you want it to put the files. So you're telling it what folder to put all those files into, the HTML files. But in the IntelliJ, it's going to ask you to configure it. It's going to say, well, for this project, where do I put all the Javadoc files once I've generated them? So you'll have to set that option. Maybe it'll prompt you the first time for what folder you want them to go in. Okay, so after you run it and generate your Javadoc, that's the folder that it's going to be in. Now, I don't want you to turn in 20 or 30 files. I don't want you to have to zip them up into one file and submit the zip file. I don't need that level of scrutiny on what you did. So what I ask you to do is run Javadoc to create those files. Open up the HTML file, just double click on it in your browser. So you'll open it up with your browser and you'll be looking at it. Now the next thing that trips people up is, I don't want to see just some generic Javadoc page that doesn't tell me anything. I want you, number one, to put enough comments into your code that in the view that you're looking at ends up telling me your name, the project, the class, you know, COP 2800, and so I can see when you capture that screen, your name and the project and stuff, and I want to see in the view something about the classes and the methods. Now, I don't need, again, 8 screenshots where you show me every method and every property of every class that you created, but something representative that just shows me, yes, I do know how to use the Javadoc feature, and yes, I did do it and it generated the comments correctly, and yes, this is a screenshot of my project for this program. That's all I'm looking for, okay? Just connecting the dots. So with this next project, you'll turn in your Java file like normal, and then something like an image that shows me that you did the Javadoc stuff, okay? So yeah, file that away, hopefully you'll refer back to it when you need it, when you're about to turn in your stuff. So moving on, typically, we haven't talked about this. We have a hard time getting through all the Java material this semester, but there's so many different little tangents that we could go. We could go into web services. We could go into Docker containers. We could go into writing Java for microcontroller devices like Raspberry Pis and things like that. We could go all kinds of different directions with it. Another thing that we could go into is the build process. This is, DevOps are a big need for companies. And so much so that it's surprising that we haven't ever developed a class on DevOps, because learning about these build tools, like IntelliJ is sort of its own build tool. Like you can say, well, I want to create a project and here's my Java files, and it will kind of, okay, there's your Java files, let me compile them, let me put the, so it can manage that, but it also knows about all of these other build technologies. Maven is a very popular one. So in Maven, you could get rid of IntelliJ, and just from the command line, you could use a tool like Maven to orchestrate your build. Point it at your source files, it'll compile them, it'll take the bytecode and it'll put it over here, it'll package that bytecode and publish it to a server. There's tools that go from the very basic to the very advanced, for large production environments with multiple clusters of servers interacting with each other. It's a whole thing to have to learn. But the only reason I bring that up is to point out you will have to manually run Javadoc, every time you want to, or before you turn in your project. But typically in development teams, it's just another step of your build script. So you'll have a Maven line at the end of the build that says, oh, by the way, also go run the Javadoc thing. So you'll never even really think about it. You'll modify your Java code, check it into Git, and sometime later you'll notice that, oh, the Javadoc out on the server has been updated with your latest changes automatically. So that's the only thing I'm pointing out is, yes, you're doing it manually here, but you won't probably have to do that when you get working at a company doing Java. Yeah. Okay, so getting back into our classes, that's going to cut the topic for the structured documentation and Javadoc stuff that I meant to tack on to the end of the last class, but we didn't get to it. So now we're going to jump back into the notion of classes. So last time we learned, methods are nothing more than terminology for a function that happens to live inside a class. A property is nothing more than a variable that lives inside a class. Okay, that's most of what we wanted to get across last time. Reiterating some of the terminology here of object-oriented stuff. So a class is a new data type, one that we created, and it's basically encapsulating the notion of some abstract object that we're thinking of. We think about this cat, and we're going to encapsulate the behavior and the attributes of a cat into a class, and that is the object that we're going to use to model the cat. So a class is composed of methods and property. So composed just means that when you look at the definition of the class, it has a bunch of variables that we're going to call properties. It has a bunch of functions that we're going to call methods. To use a class, we instantiate it. Again, not the static ones, but a regular old class. We instantiate it using the new keyword to create an instance of it. When we call one of these functions or methods of an object, we invoke it. That's what we call that. When we do the same thing with a variable or a property of a class, we're being said to access the property. Who does it? Well, we have some kind of an entity that we call a client, but it's whoever is going to be calling the method or accessing the property, invoking the method or accessing the property. And they're going to need to be passed or have available or create an instance of that object, and they have to access the method or property against that reference to that instance of an object. The reason why we do this is for reusability. If we encapsulate an object into a class, then we can create many instances of it. We can also inherit from that, which we'll get into inheritance. We'll introduce it at least. Yeah, and this is the reason why we did this. In the old days of just procedural, we reached the functional limits of procedural programming, and what that looks like is you have a library of source code that contains hundreds, if not thousands, of functions that are all at the top level, and one is at the same level as every other one. And there's a tree that you can express, or a graph that you can express, of which functions call which other functions, and those get crazy, and the interdependencies and the coupling between different parts of your source code starts to become unwieldy to the point of being unmanageable. Okay, so by encapsulating some of these things into classes, we're grouping the related functionality together and making it a little bit better organized and setting it aside in ways that we can hopefully put a layer of managing it on top of there. As you can imagine, people can go overboard with that too, and define object hierarchies to the nth degree and get right back in the same place where this is crazy. And there are metrics we could talk about to know where the sweet spot is and the balance in the middle of it. And that'd be an interesting thing to go into at some point. Is there's some really cool tools out there. I think it's called Depends or Net Depends or something like that. But there's a tool that does nothing but read source code, connect construct that graph, that call tree between objects and between methods of those objects, and tries to measure and quantify the level of coupling and cohesion between different parts of the code. And then the really valuable thing of that is it sets thresholds, because empirically computer scientists can think about those metrics and say, here's the breakover point where you're doing it too much to a point where the code has become unhealthy. And another really valuable part of the tool is that having assigned those metrics and the thresholds for them, what's good and what's bad, and assigning judgments, you can sort the list and put the things that are the highest offending bits at the top, which gives you basically a to-do list. You say, how bad is my code, and where should I start if I want to start fixing it? And you can work from the worst offenders until you get tired or lose funding or feel like, yeah, I got to get back to work. I got to stop cleaning up the code, and I got to get back to developing new features at some point. But they're really cool. I haven't played with them in a while. I found them so valuable. The last place I was working where I was doing C# programming, I just bought my own license. That way, at the very least, I could measure my own code and see how bad the code was that I was doing, or whether I was making the code better or worse as I modified it. But it's really cool stuff. Yeah. As a reminder, we kind of talked about this last time. Static objects, you don't instantiate those. They're kind of, another word you might hear is global. But we use the term static in Java. We don't use the term global as much. Yeah, so you can have multiple instances of a non-static class. And so then that brings up a good point. If you've got, let's say, 100 instances of this cat object, and you want one of the cats to meow, how do you tell it which one of those 100 cats is the one that's supposed to meow? And we talked about having references to the objects that we create last time, and when those references go out of scope, then the ref count goes from something above 0 down to 0. And when it becomes 0, it's subject to garbage collection and gets put back in. Remember we talked about the stack versus the heap last time. So then the objects that get reclaimed go back into the heap, and that memory can be reused for something else. So yeah, we have to have those references, and managing those references to the objects is important. We have to remember what our references to those objects are and don't let them go out of scope so they don't go away. Yeah, and a class can have a mixture of them. Again, we're talking about a lot of esoteric techniques and principles and things that can happen, but whether they commonly happen or not is another thing. And you know, I can sit here and talk all day about why you would want to do this thing and why you wouldn't want to do this weird thing. But just for now, I'll just leave it at a class. It is possible, it's legal for you to have non-static things where you access via an instance of the object, and you have some static things in there that there's really only one value to them. For example, if you just wanted to know how many cat objects have been created, you could put a static integer into your cat class, and every time one gets created, bump the counter by 1. And then at any time you need to or want to, you could access that static property, and there's only one integer in memory for all of the cat classes that you created. So when would you ever want to do that? I don't know, rare cases, but you can do it. Okay, so another thing about classes is they have these things called constructors. All a constructor is a special function that gets called whenever you create a new instance of the class. So the new operator, you know, x equals new cat, the new operator calling that on your class is what results in your constructor getting invoked. A constructor will always be invoked when you use the new operator, and you know, there's a method of determining which one. If you write a class and you don't put a constructor in it, then it's going to call the default constructor. There's some basic stuff that you have to do behind the scenes of a Java program to allocate memory, initialize it, and return the reference or pointer to where in memory that instance was created. So some of that stuff has to be done regardless of what else you want to do with your object, just to allocate the memory and manage it. So a default constructor is provided whether you've written any constructors or not. However, you can, remember we use that term overload, you can overload a constructor, so there's always a default constructor, so anytime you create a constructor, you're overloading it and providing your own. Your constructor may have no parameters, your constructor may have multiple parameters, depending on what you need. And if you have your own constructor that you've added to your class, then instead of the default constructor, you don't have a default constructor anymore. So now the new operator will try to call that one. Extending that, if you have multiple constructors defined, maybe you've got one that has no parameters, one that has one parameter, one that has many parameters, then you're going to have to disambiguate. And we talked about that last time too. So when the new operator on your class is called, it's going to have to figure out which one of those constructors did you intend for me to call. And it's going to do that based on trying to match up the number and type of parameters that you're passing in on that new call. So just like any other method. But one of the big differences is, well, there's a couple of differences. With a constructor, it's just a function, but it's a function that doesn't have a return type. The call to a constructor always returns an instance of the class. So you don't get to change the return value, the return data type of it. Like with every method, you have to say, does it return an integer? Does it return void? Does it return a string? You have to tell it what the return value is of this method. But with the constructor, it always has to return an instance of the class, so there's no opportunity or need for you to define that return value. And the name of the constructor is always the same name of the class. So if I have a cat class, the name of my constructor is going to be cat, always. Another version of this, a variant of the constructor, is called the copy constructor. And it's just a regular old constructor. The only difference is you'll know it's a copy constructor because it takes a reference to the same object. So if I define a class cat and I have a constructor called cat and it has one parameter and that parameter is a reference to a cat, it's a copy constructor. And the purpose of that is typically, I mean, you can write whatever code in there you want. It could be a proper copy constructor or it could be a crappy, buggy copy constructor. But the intention is that you would take each property of the one that you're passed and set them in the new one that's being created so that you end up now having two references to equivalent copies of the cat object. So that's what a copy constructor is. I'll touch on this too. There's annotations that are special to the Java compiler, and since they have this @ sign on there, you can use them. They'll show up in your Javadocs. So I just want to throw that out there. But this basically provides additional metadata during the compilation process. The deprecated one is kind of interesting. After you've got code that's lived for quite a while and you've decided, hey, this function, I don't want to delete it, but I don't want anybody else calling it for now. So you can mark it as deprecated, and that tells everybody, they'll get a warning when they try to call that in their code. When you compile the code, it'll say, oh, you do realize you're calling a function that's been marked deprecated? You might want to look for the new version of this or do this a different way. And another one is overrides. So when we have, when we're get into inheritance and we're deriving classes from others or implementing interfaces and things like that, the base that we're deriving from may already have a function with the same signature. And if we're going to change the implementation and provide our own implementation, we're overriding that functionality. So the compiler just wants to make sure that you intended to do that. So you'll mark it as overrides with that annotation to let the compiler know. And it's, again, like many of these features, this is a very powerful tool. There's lots of cool things that you can use it for. Aspect-oriented programming, a lot of it involves serialization. If you haven't come across the term serialization before, sometimes when we have one of these objects and we want to write it to a database or to a file, we can serialize it. Another thing that you can do is, if I have this process running on this machine and I want to transmit the object to a process running on some other machine over the network, then there are network protocols where I can serialize the representation of this object, and then I can pass that serialized object across the network, and the other process on the other machine can deserialize it back into an instance of the object, and it makes your objects portable. So that's kind of cool, and a lot of that is managed with annotations, or can be. So just know that those are there, they're pretty cool. So I wanted to do a quick example, give you some practical stuff here. Got my IntelliJ. What do I want to call this? Machine. Yeah, whatever. Don't add sample code. Okay, so you guys have seen this. It creates this folder structure, puts some files in there automatically. It's got this source folder. And I wanted to point out, one of the students last time after class mentioned to me that I have not pointed this out to you before. If you can tell, it's hard to tell on the screen, but if you're running IntelliJ on your own, you notice the little folder next to the .ida is gray. and the one next to SRC is blue, well, who cares what the colors are, but they're different colors. Well, then there must be some difference between those folders, right? And I can create additional folders. Well, they call them directory, okay. So I can create another folder called My Code, and notice it's gray also. And I'm pointing this out because where you would have hit this is if you have already created your project in GitHub, like I told you to do, the homework lifecycle, you know, and then you cloned it locally, and then you opened that project or folder in IntelliJ, you might see that all of these folders are gray. None of them are blue or whatever color. The thing is, you need to do something. And it's something specific to IntelliJ. You have to right-click on the folder. So the source folder is already set up this way. So I'm going to right-click on this new folder that I called My Code. And all the way down here at the bottom is this Mark Directory As. And notice the little blue folder says Sources Root. Whatever that means, right? Turns out IntelliJ expects you to tell it which folders are going to contain Java code and which aren't. And then when you hit the compile button and you want to compile this project, it expects only the folders that have been marked as sources root to be ones that it goes and looks for Java files in. Okay? Very important thing to know about if you're using IntelliJ to do this, and my apologies for not pointing that out, can cause a lot of angst, and I apologize for that. But when I mark it as a sources root, now it is blue, just like the SRC folder. You know, you may end up having lots of folders and subfolders, and you know, big projects can have hundreds of folders, right? Full of all kinds of code. But you always have to go the first time and mark them as a sources root, or it will not compile the code inside there. Okay? So very important. My apologies. But hopefully that solves some of the head beating on the desk problems that you might have encountered up to this point. Anybody else hit that? See a couple hands? So yeah. If you're using IntelliJ and you were following the instructions of creating your GitHub project first, I guarantee you would have hit that. And hopefully that's a smack the forehead moment and now you realize. But again, the more frustrated you are about hitting a problem, the better you remember it once you find the solution, I have found. So, you know, it's not all bad that we forgot and we ran into that. It's not bad, it's just unfortunate. Okay, so got my stuff set up here. I'll go ahead and delete that folder that I don't need. All right, but right now there's no files in here, so I'm going to right-click, new Java class, pay machine, public class pay machine. Okay, and remember I have to go to the settings. And it was something about editor, general, change font size with the control mouse wheel. Okay. And now I can make my code bigger for you guys to be able to read it. So you have to remember this stuff too. Okay, so let's do / asterisk asterisk. Enter. So as soon as I hit the 2 asterisks and enter, it automatically added the lines to complete the block of code. And now I can add my description. This is a class about a program to calculate my work pay amounts. Okay, I have to have a public static void main. It takes an array of strings, which are the command line parameters. So now I have a main function. What is it? Print ln. What is the print command in Java?
System.out.
Huh? Oh, yeah, thank you. Pay machine. And this is just something anytime I create a program that I like to do. So if I was creating a utility or something at home, I would just always put those 2 lines. Kind of a welcome message, a title message, to remind me when I run it what this program is. And this is mainly to be ironical, not because I expect to copyright this, but it is what it is. And then I might even have some stuff like talking about usage. Or since it's Java, I would say Java, pay machine, and what to pass in. But I'm not going to do that here, but there's other stuff that you can put at the beginning of your program. Typically in an academic environment, I expect you, again, just to get the muscle memory, not because it means it's a better or worse Java program. To do this, because what I typically like for people to understand is my program begins, and then it does a bunch of stuff, and then at a certain point my program ends. In structured programming, that's the pattern that we want to emulate. Absolutely, there's reasons why you would deviate from that in valid, legitimate cases. But again, this is an academic environment. We're talking a lot about the happy path, the ideal case. And to me, just training your brain to understand that. How does my program get invoked? What does it do? And then how does it end gracefully? It's just an important way to train your mind. And so I like putting the thank you message at the end, just so that I remember, yeah, it is going to do some stuff and then come back to the normal flow and fall through at the bottom. Okay. And then in the middle here, then whatever code that I'm going to write inside here. And so most of my programs, whether I do anything useful or not, are going to start out looking a lot like this. There's a tendency, my Python students do this too in the intro class, of using sys.exit. Oh, I'm done with what I was going to do. The users told me quit to exit, so just call sys.exit and end right there. That's not a structured way to write code. So don't emulate that also here in Java. There's equivalents in Java where you can just say, oh, I'm done, terminate the application. It used to be programming environments were really bad about leaking memory, and doing something like that was a good way to leave resources not cleaned up, leading to eventually you have to reboot your computer because it's gotten so messy out there. It's like not cleaning your room before you leave for the day kind of stuff. But you don't have to deal with that too much anymore, and especially in C# and Java, because they're garbage collected development environments, runtime environments, and so most of the stuff that you use, as soon as it notices you're done with it, it's going to reclaim it for you. But again, we're trying to train our minds to do things a structured way, so yeah. Okay, what was I doing? Oh yeah, so I wanted a constructor. Well, this isn't the class that I was going to create, so let's set this aside for a moment, and I'm going to create a new class, and I'm going to call it payment calculator. Okay, so I have a new class called payment calculator. It's public, that's good. I come up here at the top, slash, asterisk, asterisk, enter. This class encapsulates the behaviors needed to compute pay given appropriate data. Okay, good enough, whatever. It gets the point across. So inside here, I'm going to create a constructor. And so what did I say the two things about a constructor are that differ from a function? Anybody remember that far back? I know it was like 12 minutes ago.
They don't have a return type?
No return type, so I don't have to type void, correct? And then the other thing is, that was interesting. It's got it crossed out. Okay, never mind. The other thing was it has to have the same name as the class. Okay. Oops. Ugh. Just makes me feel dirty to put the squigglies on the same line. But I don't really have anything for this thing to do. So, do I really need one? And essentially, this is synonymous with having a default constructor. It doesn't do anything more or less than the default constructor would do. In essence, the system.object, system.lang.object constructor, which would be called object, right, because it's the same name as the class, would basically do this also, would just accept no parameters and do nothing. But like I said, all the behind the scenes stuff is still going on. But we'll leave that here. In any event, that's what a constructor would look like. Typically, you're going to have stuff like float, salary, and so inside your constructor, you might have something like that. So you'll just enumerate all of your variables or properties of your class, and you'll just initialize them to whatever you want them to be set to. Again, it's a little unnecessary here in Java because the float data type, when this object gets instantiated, it's going to create a float, and the float's going to be initialized. This is another big debate that goes all the way back to the early 90s. Back when Microsoft C++ compiler was competing with Borland's C++ compiler, the two big names in the marketplace, and there was a difference on many points on philosophy. And the Microsoft compiler people had the philosophy that when you allocate memory for new variables, they should be initialized to a value. Borland was, if you wanted to initialize it to a value, you would have initialized it. So quit being a dictator and make me initialize my variables. It was just two different camps. I'm sure you can imagine the same arguments going on between companies today. So Borland completely went the route of we never initialize anything for you. If you want it initialized, there's your opportunity. You've got a constructor, you can initialize it. Where Microsoft said, no, when we allocate your class, we're going to set everything to its initial default value. So then Borland would complain that, yeah, well, our compiler is faster than Microsoft's because of all of the extra code they're executing to initialize their variables. And Microsoft would complain, well, yeah, the Borland compiler isn't as good as ours because they don't initialize their variables, which leads to security concerns. You know, who knows what's in that memory? And it went back and forth. But C#, Java, modern interpreted languages like this, or intermediate languages like this, they're going to initialize your variable for you. So there you go. Okay, so we've got a constructor, and I'm going to add some methods. Let's say, let me add another property up here called hours. And let's leave it integer just to be different. Hours equals 0. Okay, so I haven't done anything too terrible here. I've got a class with two properties. I've got a constructor that initializes those two properties to initial values. If I come back over to my main function, now I can say payment calculator, no, autocomplete. So now I can create an instance right? And I could theoretically so I didn't need to put these on here because it's print line instead of print. Help me out here again. What's the print format stuff in? So this is how I would do it in C#, but how do I do it in Java? Huh?
I think it's where the ln is, you should have print f, I think.
Okay.
To concatenate the strings?
I think that's it.
You think that's it?
Yeah.
Why is my hours? There we go. Let's see what happens. Nope.
Put it inside the curly bracket. Put the p that hours inside.
Just p.hours. Like the Python way. There's a name for this kind of strings too. I forget what it is. No.
Can't you just add it with a plus sign?
Yeah, I can.
Would that work also or no?
what do you call this kind of string? Yeah, I mean, I don't apologize too much for this. Again, I deal with too many programming languages to remember it. So it's the 0. Okay, it's just string.format then. Placeholder. All right, what are you complaining about now? Doing the message format, but I thought I could do that with string.format. Oh, there's that guy Beldum. See what he has to say about it. Oh, %s. There we go. That's the magic. So we don't use the curly braces for the placeholders. We just use the percent and type specifiers. And then I do need the \n, since I'm not doing print line. There we go. Okay, so if you can't see that, it says hours equals 0. So I printed my welcome message. I created an instance of the payment calculator object. I didn't do anything else to it, so the properties would have got set to default values. And I can prove that by showing that printing p.hours. So I always have to use the reference to the object that I created and saved, .hours. And then prints the thank you message, and then it hits the closed curly brace down here, at which point all of my local variables, including p, go out of scope. Reference count goes to 0. Garbage collector puts it back out in the heap for reuse, and my program exits. Okay, so very simple starting point example, but it works. So I'm going to go back over to my payment calculator because I'd really like for this to do something. So the next thing I'm going to point out to you is this is one way to create properties, but there's another way to create properties. If you're not going to do anything with them, then that's not terrible. It's not illegal. But there's another way to do this, and it's basically creating getters and setters in our code. And what that looks like is, let's say I want to create a property called base hours or base pay or something. The other thing that I probably should be doing is making these explicitly public if I want to access them that way. But let's change that to base pay, and I'm going to make this protected. Now we talked last time about public and private, so this is the first time we're going to actually talk about protected and see it in context. Typically, by default, if I'm going to put variables inside a class that I'm going to expose via getter setter like I'm going to demonstrate, I'm going to make things protected. And what that means is if I ever want to derive a subclass of this using inheritance, then that inherited subclass will have access to this variable. If I make it private, it won't. If I make it public, well then there's no restrictions. Anybody can have access to it, which I don't want. But if I make it private, I'm basically telling my kids, you know, I'm being like Bill Gates with his inheritance, saying you get nothing to his kids, right? So by making things protected, the general people accessing your object don't get to see it, but the people derived from this object would get to see it. That's where we would use protected. So that's our third main protection class specifier. Private, protected, and public. So I'll make both of those public, or protected, and then let me create a getter and setter. So if I'm going to get that, it's really nothing more than a function that returns that value. It'll be public because I want everybody to be able to access base pay this way. It's going to return a float, and I'm going to call it get base pay. So it's not magical, it's just a function that returns that variable. Because like, what's the bother, right? Why would you do that? Similarly, if I want to set it, if you're going to set it, it doesn't return anything, so I return void set base pay, but I have to pass it a base pay value. Now, I could have said B right? I could have implemented this like this. Base pay, which is this, equals B, which is the parameter that I passed in. But if you noticed what the little type ahead thingy suggested, it gave us an idea for a better pattern for doing this, which is use a good name for a variable, but if I say equals base pay, does anybody remember the word for why this is bad? We talked about it last time when I have multiple things named the same.
It's ambiguous.
Yeah, this is ambiguous. The compiler says, I don't know which base pay you're talking about. You've given me two things called base pay. One of them is this protected member of this class, and the other one is this parameter that you expect people to pass in. So you're overloading the name of that, which is fine, you can do that, but now you have to tell me in this expression what you're talking about. So I need a way to disambiguate this overloaded name. And while I don't have a good way to say, like, they could have said, say param dot base pay, that would have been a way to say, no, this one I mean that parameter, but they didn't give us a way to do that. Instead, they gave us a way to refer to this instance of this object. So that's the way you would do this. I'm just going to drop this down so we can see the whole thing. That's a little bit easier to read, right? So that's the way I would do this. So here's my getter. Again, it's just a function that returns this value, and then a setter to pass it a new value, and it changes the value of this local variable or this class member. All right, so that all of these lines of code, that is how you would implement a property with a getter and setter pattern. You have to have the underlying variable, typically make it protected or private. You have a getter and a setter. Any questions about that? So yeah, properties of classes are not magic. Just you have a getter and a setter and an underlying variable. And then I can do the same thing quickly with hours. I've got the underlying variable, it's already protected. So now I've got getter and setter for that. So now if I come back over to my main function, okay, so I've created a new instance of this. So now I'm going to modify it. So I have a reference to a payment calculator. Instead of P, I don't want this to turn into a do as I say, not as I do. I'm going to give it a little bit better name. But that means I have to change it down here too. So if I'm going to change the hours and the base pay of that instance of that object, payment calculator is the reference to the instance. Yeah.
You don't need the string format inside the bracket because it's already formatted when you use printf.
Thank you. Getting better all the time. Yeah, so printf automatically expects it that way. So it wasn't working before because I was using the curly brace placeholders. Okay, thank you. Dot. Now before, I was just saying hours. You know, I was accessing it directly. But now if I do that, it should pop up something here. Let's see if I try to run it. Oh. Oh, here's another thing. Notice how my little green triangle at the top went away? You can only build if you're looking at the function that has the main in it. Now it comes back. That might be another thing that frustrates you about IntelliJ. You'd think that you could just build the project, but no, you have to start with the class that has the main in it. Okay. See, that worked. That should not have worked. There's something else going on here with protection. Because this is protected, that should not have worked. Let's see if I make it private. Two related problems. Yeah, ours has private access. So for some reason, making this protected left it accessible over here. One theory that I have is that because I properly created a property with a getter and setter, that the Java compiler looks for that pattern and says, oh, what you meant was to be able to call that by accessing it via the hours we can verify that. Is this modifying the variable directly, or is it calling my function that is called set hours? So if I come over here and look at the set hours, I can say you set me. Yeah. So if it's accessing the variable directly, I won't see the output message. If it calls set hours, I will see the output message. Make sense? So it didn't. It accessed the property directly. So then something else is going on. It's not calling this. It shouldn't have access to this. Okay, I'm going to have to look that up, unless somebody else comes up with a reason for that. So I'm going to set that back to private. Yeah, now that's what I expected to get. I get errors saying that you can't access it. Because what I'm supposed to have to do is say get hours.
Yeah.
I have to call the getter. Get base pay. And then change the hours. I can't do it like this. I have to say set and pass it 12. So I'm using the getter and the setter. Okay, and then likewise, payment calculator, set base pay. How much per hour do we want to give them? Let's say $50 an hour. So, okay, let's say they work 52 hours. Hard working. And I'm going to, again, print the value of those properties. Okay, let's see what it does. So I got my welcome message. I created an instance of it. I printed the values. They're set to 0 and 0.0, the initial values, as I expected. It did call my setter because I see my print message. It now says the correct values that I set those to, and then I got my exit message. And if it's not obvious, this is kind of the workflow you'd expect. You're going to continue iteratively adding functionality, running it, see if it works up to that point, adding more functionality, running it to see if it works, till you get enough. Now, another thing, this is where I wanted to point out, why would I go to all this work of creating these getters and setters? Because I set the hours to 52, but what I really want is, I also want to track private and overtime hours. With a getter and a setter. But, now here's the interesting bit. If they set the hours to 52, well, that includes a certain number of regular hours and a certain number of overtime hours. So one of the cool things that I can do here is I can intercept that setter, and I can say, get rid of this. If hours is greater than 40, this dot hours is 40, and this dot overtime hours equal hours minus 40. So something like that. Anybody have an issue with that? If I do something obviously wrong? So you pass in 52. Well, I'm going to assume that you passed in something less than or equal to 40, and I'm just going to set those values. But then I'm going to say, well, if you pass in something over 40, let me change them to the correct value, which is setting the regular hours to 40 and the overtime hours to whatever was above 40. So now, if I set the hours to 52, that up here, and I'll add another block that does the same thing. So I'll set it to 38. If I run it, okay, initial values, then I set it to 38. I get overtime hours is 0, and hours is 38. That looks reasonable. But then I set it to 52, and I get overtime hours is 40, or hours is 40 and overtime hours is 12. Pretty cool, huh? So no matter what value they pass in the setter, I can split that into my two internal behind the scenes variables so I can keep track of how much is regular and how much is overtime. Pretty slick, huh? So that's one reason why you would use a getter and a setter instead. I could also implement this the other way. I could say, just do this the regular way. I could get rid of my overtime. Where's my overtime? Get rid of that value. Well, I'm not going to get rid of the whole thing, so let me do this. Okay, so on hours, I set hours. I just set it to the value that I pass in. But when I say get hours, I can say if hours is greater than 40, return 40. And on overtime hours, I don't need a variable. I don't need a setter because there's no variable. And on the getter, I can say if hours is greater than 40, return hours minus 40. or return 0. That make sense? So I'm doing the exact same thing. I've changed the back-end internal implementation of that object, the way it's been encapsulated. And if I run it, I still get the same and the correct results as before, 40 and 12, 38 and 0, but I've got a completely different implementation. And the client, the main function in this case, is none the wiser. I implemented 2 completely different ways, and the person writing the main function doesn't know or doesn't care. Pretty cool, huh? And that's one of the reasons why you want to use getters and setters, is because it gives you that flexibility. Like the first time I naively implemented it, I thought, oh, well, I need an hours variable and I need an overtime hours variable. Obviously, right? But then I got clever and I thought, wait, I can implement this without the second variable. So I made my function leaner, less memory required. I thought of a better implementation in my mind. So change the implementation. But as long as you value the contract and you honor the contract that you created, which is the contract of a class is its public properties and methods. As long as you honor that signature of that class, nobody cares how you implement it behind the scenes, as long as you do it correctly, obviously. And what that does is it leads to what we call loosely coupled software implementations, which I highly value, loosely coupled software. The client is not over-dependent on the implementation details of what it consumes. Okay? And okay, let me do the Javadoc thing here so you see an example of that. Because all I did really was added my comments here. So let's see, where's the tools? Tools, menu. Where's tools? Tools. Where is it? Where is it?
Hit menu again.
Menu.
Over on the top where
Oh,
you have
up here. Tools. Ugh. Menu. Tools. Where is it? Oh, generate Javadoc. Boom. So again, the first time I did this, it prompted me. It says, hey, where do you want me to put all this stuff? Yeah, process the whole project. No, I don't want to include the JDK and the library stuff. Otherwise, it's going to start trying to generate stuff for your system.out and system.lang and all that other kind of stuff. I just wanted to do my part of the stuff. Generate all this stuff. Yeah, here we go. Output directory. So I can go, let's say I'm going to put this in my downloads folder. So that's where I wanted to put my Javadoc stuff. And then click generate. So it generated, I saw a bunch of red there, so I probably did some stuff wrong. But it generated it and opened up the HTML page that resulted. And I see my classes, pay machine and payment calculator. If I click on payment calculator, look at that. It has all of my methods listed, has method details. Now see, it doesn't have any description information on these methods because I didn't add any. So that's for you to add, and you can put the attributes about your parameters and stuff too. I'll let you look at how to do that. But this is what it generates, and it's pretty cool looking. All I had to do is add some comments to my code, and I get all this stuff for free. I think that's pretty nifty. So you would want to make sure, like I said, that you add enough comments in here that it shows your name, the class, the the project, that kind of stuff, and other appropriate comments on things. And then, if you just screen print this and send it to me, or turn it in, that's what I'm looking for, to show that you know how to use Javadocs, that you added the structured comments, you generated it correctly, you found it and viewed it, and had some meaningful content in there. Okay, let me set that aside for a moment. Yeah, so went through the properties. So just a few other little tidbits here. We have 8 data types that are built in that come with. You know them already. I mentioned this briefly, I think, before, that behind each of these types is also one with a capital, like capital INT, variations of these. Those are the classes that wrap the underlying data types, and that's where they have the opportunity, since it's a class, to add a bunch of methods and properties and things that you might find useful, like converting it to other numbering systems and things. So I hope you explored some of that already with the project that was already due. Yeah, so we already kind of talked about this some. The new operator we talked about, the this reference we talked about. Oh, you can call, let me show you that briefly, how that would apply here. So I've got my payment calculator class, and I kind of bypassed, I have this default constructor, but let's say I want a meaningful constructor. I could create a constructor where I accept the parameters, and I set the parameters based on what they pass in. It's gray because there's nobody using it right now. So not very different. This one initializes it to default values. This one initializes it to whatever they told me. So now I can go back to here, and like if I put these values in, I essentially get the same thing. What? Oh, typo. I essentially get the same behavior because the default constructor was going to make these 0 to start with. So that's not very helpful. But, so what I'm doing here, I would say that I would describe the payment calculator class, it's mutable. It's not immutable. Once I get a reference to this, I can change the property values of that object and cause it to be reflecting something different. Immutable objects are objects that by intention, we intend for them, once we create them and set the properties, they don't change. They can't change. They never change. I could create a different instance of the object with different values if I wanted to, but I can never change that original instance and change its properties. That's especially with the advent of trying to make our code more secure, less vulnerable to attack threats and vectors and things like that, with the cybersecurity in mind. Immutable objects are one of the inherent things that makes code like that more secure for lots of esoteric reasons that I won't go into at length, but just suffice it to say that that is part of the formula. But I can change this to be immutable pretty easily. If I come over here and I say, let's do a couple of things. I'm going to get rid of the default constructor. So I still have a constructor, but it takes these parameters. And I'm going to leave the getter, but I'm going to delete the setter. Delete the setter. So you see what I've done here? I've still got base pay and hours properties inside here. I've still got getters for them for base hours and overtime hours, but I don't have any setters. The only way to set those two properties is in the constructor now. Okay? So then I come back over here and I say, well, you know, I created the basic one. Let's do this again, 0.0f. Okay, that's happy again. So it prints the 0 one, but I can't set them to a different value anymore. That's fine. What I would do is I would create another instance of the object. Payment calculator 2, and I would set it to 38 and whatever, 50. And obviously I want to reference that instance of the object. Oh, I don't need to do that anymore. I can't do that anymore. But in the print, I want to now print this one, not the other one. So, you know, it's a subtle change, but now I've got two instances of the object. The first one is a 0, 0 object. The second one is a 38 and 50 object. And then I can do the same thing with the other one. Now I've got a 52 and 50 object. And let's print the 3, 3, 3. So I've got three different instances of the object now. Everybody see that? So now I've changed payment calculator to an immutable object. I can still use it just as well as I could before, but I just have to set the values when I construct the object. They can't be changed after that, but I can still manipulate the output the way I was before. So if I run it, yeah, so once again I get the output that I expected. And now it's immutable. So when I use that word immutable, that's what I'm talking about. Oh, and then the constructors. That's another thing I wanted to point out. Okay, I deleted my other constructor, but if I wanted a constructor that quickly creates a 0, I can go, so this is again a default constructor, or not default, this is a constructor that takes no parameters, but I can call the other okay, is it going to complain because I'm not supposed to do that? I guess this is a C#ism. What? Squigglies. Public. Well, it was public. Okay. One moment. Pay no attention to that man behind the curtains. what's my syntax? This. Okay. There you go. So in C#, you give it the name of the other constructor, which is the same name as the class. In Java, you say this if you want to call the other constructor. So all I'm illustrating here is from one constructor, you can call the other constructor. So then I can go back to it was a little awkward here to have to pass the default values the first time I called this. So now I can go back to just saying payment calculator, and I get an instance of the object back with default values. That's what I was trying to show you. Okay? Calling a constructor from another constructor using this reference. Yeah, libraries. So when we're in our program and we want to, like let's say I wanted to do some trigonometry. What was it? Lowercase Java. So the math library, if I wanted to use pi, what? Oh, yeah. Because math.pi is a double, and I would lose precision like we talked about last time if I didn't typecast it as just a float. So it says, you're going to lose some of those digits. And I'm like, yes, I know I'm going to lose some of those digits. But that's how we import and use libraries that have code that other people wrote, which we want to do, as often as we can, because the assumption is, while it may be fun to reinvent the wheel and solve a challenge by implementing some algorithm that we think would be fun to implement, the reality is that if it's in the system libraries or in some library that we've purchased or we're importing, that it's already been written and tested and validated against lots and lots of other people who have used it. It doesn't mean that you'll never find a bug in that code, but typically, in general, code that somebody else has already written and tested is more reliable than code that you would write yourself. And I guess we can extend that notion to now with AI, except with the caveat, I wouldn't say code that you get from AI is more reliable than code that you could write yourself. I think people are making this point abundantly clear, and it'll be interesting over the next few years to see how this continues to evolve. But I don't know if you've heard the stories about the AI situations that they're coming up against, but they train these AIs and they validate them to make sure that they're quality, and they have tests, like performance suites that they run against new AI models. And what they're finding is that the AIs are getting smart enough to behave optimally when being evaluated against these tests. And then once they get put out in the wild, they go back to themselves again. Well, what does that sound like? Does that sound like kind of like a first date maybe? So now AIs are learning first date behavior, but I find that really interesting. Or that they will lie to the people who are using them in order to achieve some other goal that they have separate. I mean, just the reasoning and all of the combinations of stuff that's going on is just out of hand. But the point I was making was, if you ask the AI to build some object or to implement some method for you, you just take that as if your little sister wrote that code, and you're going to have to go through it line by line and make sure that it's correct. The amount of time, in my personal experience, the hallucination, of course it varies from model to model, but I mean, sometimes you get, depending on the complexity of the problem, as much as 80% of the time it's hallucinating. It doesn't produce the right results. at all. So you just have to be careful with it. But yeah, if it's part of the Java standard runtime library, you can probably rely on it being pretty good. Yeah. Wanted to point out, just because we haven't talked about it before, there are date time classes. You know, we've talked about integer and float and string and all that, but there are date and time classes which are kind of interesting, and they have lots of useful methods and properties in them. But going back to our example here with the base pay thing and the hiding the implementation, I just want to throw this out there. What is the internal representation in that local date object if you create an instance of it? Inside, is it holding on to some big number of seconds past some date or milliseconds since January 1st, 1970? Or internally, does it have methods for, or variables representing properties for year, month, day, hour, minute, second, millisecond, etc.? Or does it have a string representation of it? And do we care? As long as that list of methods and the properties that we can access fulfill the contract of that local date class, generally we don't care about what the behind the scenes implementation is of it, with exceptions. Of course, you know, I don't have time to get into it, but you know, at Microsoft, one of the things that I did was fix a lot of the daylight savings time logic behind the scenes, and where it would, you know, run things twice because it skipped over daylight savings time changes, or not run things at all because it jumped past it. And it turned out to be that there's half a dozen different places throughout Windows that it represents date times and passes them between layers and different representations inside. They would lose that daylight savings time setting from representation to representation. So I would say that represents a breaking of the contract of the date time value, the date time object that has been encapsulated. And that leads to logical errors downstream. But, you know, in general, when we define what the contract of an object is and we implement it a certain way and it's correct, we don't care about what the implementation is. Another terminology thing I want to throw out there as we go is composition, and that has to do with the is-a and the has-a relationship. We talk about that a lot in object-oriented programming. So my example here is if you are implementing a zoo class and a tiger class, we would not say that the zoo is a tiger, so you wouldn't put the methods about a tiger into the zoo class. Okay? This is all under the heading of what we introduced last time called functional decomposition. It's how we encapsulate our objects. It's where we put the functionality, and it needs to make sense. So a zoo object would have an instance of or a reference to a tiger object, but a zoo isn't a tiger, so the zoo wouldn't have the methods and properties in the zoo class, is the point. Likewise with inheritance, a tiger and a cat are both felines, so you would have a feline object that has stuff that's common to both a tiger and a cat, but then the tiger would implement the things in such a way, you know, the behind the scenes implementation, when you ask the tiger to speak, it would roar. You ask the cat to speak, it would meow. It's the same method, but they both implement them in a way that makes sense to that particular object. And we'll get into all that kind of stuff later. And that's hopefully the end of this stream of consciousness. And we'll pick up next time. You've got an assignment coming up that will include the things that we've been talking about and the Javadoc stuff. So any questions, let me know. And I will stop talking.